All right, in this video, we are going to sketch this cosec function over here, and we are going to sketch it between -2 pi and +2 pi. Now, the first thing we even notice in this question is that this is not fully factored. We're going to start by factoring this 3 out over here. I'm just going to start by doing that. I'm going to factor out the k value. I'm going to be left with pi over 2 divided by 3 is just pi over 6. Now I'll just do some of the key features of this graph. So I know that my amplitude is 2. My k value is 3, which means my period is 2 pi over k, which is just 2 pi over 3. I have a phase shift of pi over 6 to the left. And my equation of axis is y equals to 3. Now, I know that I'm sketching between -2 pi and +2 pi, so I want to draw my y-axis in the dead center. I'm going to start by putting my equation of axis in the middle. I'll make this span the whole page because you might need it all. So this is basically at a y value of 3. And then I'm going to find my maximum and minimum over here. So my maximum is just my axis plus my amplitude. So 3 plus 2 is 5. And my minimum is 3 minus 2, which is 1. This means that my x-axis is going to be slightly below 1 over here at 0. So I can just draw my x-axis out. And now I can start to draw out my function. Before I draw out my function, I want to think about my phase shift, and I also want to think about my period. My period is 2 pi over 3, and I'm sketching between -2 pi and +2 pi. That gap over there is a gap of 4 pi in total. If I divide 4 pi by 2 pi over 3, I will get 6 cycles. So in this question, I'm going to be drawing 6 cycles in total to fill out this graph from -2 pi to +2 pi. So you want to make sure you draw the graph narrow so you have enough space to fit 6 whole cycles in this question. Now, rather than draw a cosec function straight away, I'm going to start by drawing the reciprocal, or at least doing the points for the reciprocal, which is a sine function. So I'll do this exact same function here with the sine function, because sine is the reciprocal of cosec, and then I'll use that to draw my cosec graph. So let's think about your key points for a negative sine function. A negative sine function normally starts on the axis over here, but we're shifted pi over 6 to the left. So normally I would start over here, but I'm shifting pi over 6 to the left, which is basically going to be, I'll keep it pretty close to axis because I want to make sure I fit this. I'm going to keep this point over here, which is basically negative pi over 6. The next thing I want to do is I want to find my interval for this function. So I know like where my next key point is going to be. In order to find your interval for a cosec function, you always take your period and you divide by 4. So 2 pi over 3 divided by 4 is just pi over 6. So my interval from one key point to the next is going to have a difference of pi over 6. So now I'm going to fill out all my points from -2 pi to +2 pi. I'll go in the positive direction first, and I'm going to show you an easy way to do this in your calculator. So you want to just start by taking your first point over here, which is -pi over 6, and then just hit the equal button. And then calculator is just -pi over 6 there in a slightly different form. Then you want to just click plus and add your interval, which is also pi over 6 in this question. And then you want to just hit equals. So my next key point is going to have an x value of 0. So next point for negative sign function, we go from axis to a minimum, which is an x value of 0. Then I'm going to hit the equal button again for my next key point, which I'll get as pi over 6. And I'll keep hitting the equal button, keep getting the next key points. This is a really fast way to just get all the key points and go all the way up until 2 pi. So these are all my next key points, basically. I'm going to put them all on the graph now, but I just showed you a really quick way to calculate it in the calculator. I'm going to start it and do the process again, but I'm just going to write the values down now. So negative pi over 6. The next one is at pi over 6. It's an axis point. Next one is the maximum, which is at pi over 3. The good thing is the calculator will automatically reduce everything down for you as well. Next axis point is just pi over 2. Keep adding pi over 6 basically to all these points. Next one will be 2 pi over 3. Next one will be 5 pi over 6. Next one will be pi. Next one is 7 pi over 6. Next one is 4 pi over 3. Next one is 3 pi over 2. Next one is 5 pi over 3. And next one over here is 11 pi over 6. And then last one is going to be at 2 pi, because if we want to go from negative 2 pi to positive 2 pi, so I filled out all those points there. You can use the exact same process to get the negative points here. So just start with negative pi over 6 equals, and then just keep subtracting your interval, which is pi over 6. And then you can just keep hitting the equal button to get all the answers. So that's what I'm going to do. I'm not going to show all the calculations, but I'm just going to write them down. I think the values will be the same as these as well. I think they'll be all, yeah, because technically in this question, all the values will be same, because if you notice the gaps here, the gaps are the exact same in this one. But that's not usually the case for most questions. It's very rare, and only if your graph is an even function, basically reflects in the y-axis, then the values are going to be identical. So negative pi over 2, negative 2 pi over 3, negative 5 pi over 6, pi, oops, negative pi, negative 7 pi over 6, negative 4 pi over 3, negative 3 pi over 2, 5 pi over 3, negative, negative 11 pi over 6, and last one is negative 2 pi. So now we've got all the points here. Now I'm not going to actually draw out anything through these points because I don't want to actually draw the sine wave. I want to draw the cosec wave. I'm going to use these points to draw my cosec wave, and I'm going to show you exactly how. So the first thing is, for all your axis points, you're going to draw vertical asymptotes through every single one of your axis points in this question. So basically, let's start with this. I have a vertical asymptote. Oops, not the best line, but I have vertical asymptote. That's off. But at negative 11 pi over 6. Graph's a bit off in terms of the scale, but I think you get the idea. A vertical asymptote over here. Another vertical asymptote at negative 7 pi over 6. If you were doing this on grid paper, it would be a lot more accurate than drawing it on blank paper, obviously. Then I have another vertical asymptote over here at negative pi over 2. Another vertical asymptote here at negative pi over 6. Another vertical asymptote here at positive pi over 6. Another one over here at positive pi over 2. There's a lot of asymptotes, I know. 6 cycles, which means I think we have 12 asymptotes in total. Another one at 5 pi over 6. Another one here at 7 pi over 6. One more over here at 3 pi over 2. And thank God I've reached my last one over here, which is at 11 pi over 6. Now that I've finally drawn out my asymptotes, I can draw my points out for this graph. So this point over here, it's below the axis. So you're just going to draw it going downwards like that. And this one is above the equation of axis. We're going to draw it upwards like that. And we're going to repeat the process for basically all of these. This one's downwards. And this one is upwards, down, up, down, up, down, up, down, up, and then the last one over here. I realized I had made a tiny mistake at the start. I'll fix that now. So it goes down. I don't want to draw the other half here because I want to end at 2 pi. And on this one, I want to end at negative 2 pi. I actually didn't need this half of the cycle there. I should have just started there and gone down. Okay, so there you have it. A really, really annoying question, but that's the solution. You actually made it to the end of this video, which I would think is pretty painful because this is such an annoying graph to draw, especially freehand on free paper. But if you made it to the end, please hit the like and subscribe button and help me get to 1,000 subscribers so I can monetize my channel. This is video number 523 without making a single dollar. So I would really, really appreciate if you hit that subscribe button. Thank you for watching.